Hello, everyone, and welcome to the broadcast. I'm newtmechanist, and today we are finally back for real as far as the coding streams. We had a bit of a false start last time, but we figured out some of the errors and some of the things we're going to do, so we're going to start doing those. But before we get into that, let's check in with the kitties. We do have Ember top center, we have Sky in the upper left in the tree. We have Mason and Sammy on the bed. And let's see, Sherbet and Molly unaccounted for. Let's check real quick here. None of the really visible spots. Yeah, hey there, Dots. We've got on the table there. That is a really cheap rug. On one half, and then on the other half is a canvas tarp. One thing I found with cats is textures. You want lots of different textured surfaces. Different, different levels of softness, different materials, levels of heat. So like Ember's on a heating pad right now. Mason is on it's kind of a felt-like blanket. Kind of that sort of microfiber, micro fleece kind of stuff. Sammy is on a giant squishmallow. The cat tree that Sky is in is a coarse carpet. It's kind of a standard sort of stuff that a lot of cat trees get wrapped in. But yeah, different textures and surfaces and the like. Like Ember likes to roll around on the canvas. But yeah, welcome, Dodds, welcome. We are going to be hopping back into the game dev. So there are yes. Let me show that. What was that button? Window. There we go. It is not the window button. It's just that I haven't renamed that button. When I reorganize. Oh, there's Molly. Molly's a bit of a chow hound. She's the first one that I have had to stagger how much food I put out. Sherbet will eat a lot, but Sherbet doesn't seem to gain weight. Molly isn't getting fat, but Molly be chubby. But that fountain is the first one that I've had that I feel like it could last a while. So most cat fountains use those little kind of aquarium pumps, almost universally, this little black cube with a kind of nozzle sticking out the top and a fan in one of the sides, or a little, rotary mechanism. And the problem with those is that they wear out quick, they jam up easy, they're kind of a hassle to clean. So those tend to be a huge failure point. This does not have any exposed motor. The actual mechanical element is contained within the base. The bowl of water and the actual, water elevating mechanism are kept separate of the motor entirely. So at no point does the liquid or anything like that touch the motor. Instead, in that little kind of cylinder on the bottom of it, there is a tube that gets rotated. Well, it's kind of a cone, truncated cone. Hey there, Lore. It rotates, it pulls the water up it, and then it kind of drops in. It's pretty cool. I like it. It's easy to clean. It's all kinds of good going for it. That one is dog-sized. That's the version of it that is sold as a dog one. Given number of kitties, it is viable. It's also very quiet comparatively. Like, it's not silent by any stretch, but pet fountain-wise is quiet. Molly being one of the cats that has to randomly scratch around like the water dish. She drinks a little like Ember does. But yeah, so let's go into some of the stuff I encountered between last stream and this one. I have used so many pet fountains, Dodds. One of the things I'm looking to do is rig up some sort of like kit bashed UV lamp over it, because one of the fountains that I had that was really good, for that one particular reason, it was a hassle in most others, and it broke down because of, issues with motor and similar. But it had a UV light in it, a like properly contained, properly shielded UV light in it. And as much a gimmick as you find those, a lot of times, that makes a huge difference as far as microbe buildup in a pet water dish. Anywhere that UV light hit inside of the dish, yes, it was slightly discolored in that area, but also it was like a hard seam. It would have the like slimy microbial buildup, like that thin layer on the surface of the plastic, and then a layer or a region where it wasn't, wherever the light hit. So I want to I want to get something like that set up over top of it. It's just getting UV lights that aren't industrial grade, that won't get you on some sort of watch list, and that you can safely use near something like pets or a water source like that. Not straightforward. And most of the ones that you can find readily available online are super sus. Like, for every person that reviews it and says it works, other people will say, yeah, it electrocuted me, and then leaked chemicals. Hello, Molly. Hello. But yeah. They are real good. I've got a cheapy little USB powered like wand sanitizer. I want to try to, like, again, kind of bash together a little stand for it near the fountain and just have it over there so that as the water is like getting rotated or shifted, it's likely to hit that, maybe like near the mouth of the fountain kind of stuff, where a majority of the flow and buildup would happen. Molly is sitting on my lap, so she must get attention. She kind of likes to be, it's almost like massaged, Not as much for like stroking or scratching or anything like that. It's that sort of, knead the dough motion that a cat will do to you, but on her back. Isn't that right? Of all the cats, she's the most delicate as well, as far as her squeaking at me if I pick her up wrong or something. Okay, so we had a series of issues last time. Well, between last time and this time that delayed things. And one of them isn't actually going to be an error that would have shown up in what we're going to be working towards today, but it was uncovered in the process of moving through there. And it revealed a hole in my JSON polymorphism configuration. So let's pop in here. Okay, well, this is also an opportunity to show you C# JSON polymorphism configuration. So catalogable types info. I use this for a couple of things, but what this does is at runtime, it finds all of the stuff that falls under the catalogable heading. This is necessary because I have a kind of class hierarchy. There are like behaviors and behaviors that split into multiple things and all kinds of different stuff. And I want to be able to deserialize those from my data files. But if I try to say deserialize it and put it in a parent class, like a catalogable or a behavior, the default deserialization says, oh, it's just one of those things. It is the parent class. So best case, there will be some like data values hanging around that you would have to manually like repopulate. But if you set it up so that it knows that you tell it which things are child classes of which things, then it can set that, which is great, unless the thing that you are deserializing is the same type as what you're storing it into, in which case you don't have that special variable set to say it's one of these things. Or so I thought. So let's walk through the convolution here. So what we're doing is we're going through, and I found like a tutorial on this whole nightmare sequence that I'm going to show you. So we're going through the assembly. So this is the actual executing program. And we are getting all of the types and we're filtering them down to where they're a subclass of our core data type, the catalogable. So we find all of those and we iterate over all of them. We convert the class name, like catalogable here, into a string, which is a lowercase version of that name. So catalogable with a lowercase c kind of thing. Fun little element, we have two lower invariant here. Let me zoom in for folks that are on stream because, you know, tiny text. Invariant. This is just doing lowercase doesn't mean you will always get the same symbol if it comes in some languages. Will this be a problem in ours? Shouldn't be. But say I have text input. If you just do two lowercase, it is possible that you get a different result than you might think. Like different dialects, different languages can have slight variations in some of the lettering that would result from two lower if you use it in different regions. So we're just not going to do that. So we'll use two invariant here. But okay, so we get that type. We are going to instantiate it as a catalogable. So the root type, and we are doing that primarily for this catalog category value. I don't know if we're going to keep using this. It seemed like the thing at the time, but its use case is falling away. So it's a bit vestigial for now, but it's happening. So then, for each of these types, we get all of the children of them. Is there duplicated work going on here? Yes, but I don't care. This is once during each run. Since all of these children are actually all of the children of catalogable, so there is a little loop around, but it's kind of necessary, ultimately. So we take each thing that is a catalogable and we're saying, are there any direct children of that? Which we are going to store off. So this type has these child classes. Kind of stuff. We will use all of that later. So what this has resulted in is we have our collection of types by type name. So this is the lowercase string, a lowercase version of the class name. We have its category. This is like, currently this is all behaviors share a category kind of stuff. Again, this is kind of vestigial at this point, but I'm keeping it there in case I either remember a thing that I forgot, or if we need to come up with or we find a use case that realigns with this. For now, eventually it might get ripped out. Then we're going through and we're saying, okay, child types. So we are going to say this type has these children. It might be empty, like there might be no children for it. But we're going to say for each one of them, we're going to load it in. So this class has this collection of children. This collection of children is the type name and its actual type. All of this is primarily for JSON type resolution. Static, essentially big old singleton going on here. So then here. So this is our custom JSON type resolver. And we're looking for two different cases. I can refactor this to be a little less kludgy, I guess. But there are two different cases here. There is the root catalogable. So we're going in and we're saying, if I don't recognize the type, we're going to fail serialization. If we, we have to recognize the type effectively. Are there any other variables that I need to put in here? Let's just, I think those are all that I need. Yeah, we'll leave that alone for now. Continue the explanation. Okay, so derived type. We're going to say what this setting is for, and then I'm going to tell you the magical thing that we had to add that I don't like the way that it has to work, but apparently that's how it needs to work if we want to be 100% consistent. So derived types is where I'm saying when JSON is deserializing this or serializing this, this is how you denote which child class it is. So if I'm looking at a variable that is a catalogable, I can look at what actual type it is, whether I am writing it to file or I'm reading it back in from file. And I have a special field, a type field, with the kind of code name for it. Hey there, Ryud. Welcome. I'm explaining my custom JSON deserializer at the moment, largely justifying the extra delay between the last coding stream and this one. But what we're doing here is we're saying this this type that we're looking at, in this case catalogable, so it will be, sorry, when we're making a derived type, we say the type that is a child of this one and what its special name will be. So this is that invariant lowercase that I was talking about before. What we do is we go through and we iterate over the entire collection of, these are all the different catalogables. And we are going to make those derived types of catalogable. So anytime that I need to deserialize something, this lets me load in the child classes of it, even though I'm loading into the pretty much only informational parent class typed variable. But this is the special case that I was referring to. This is where we are saying, this is where this line, what it says is that a catalogable is a derived type of a catalogable. So the thing itself is a version of the thing itself. What this allows us to do is have this name as a type field. So it is possible for me to have a upper level parent if I am requesting a variable that fits into that same type. So I have a variable that says it's a catalogable, and I want to load a catalogable in, something that qualifies as one. But the thing I am loading is an actual catalogable, not a child type. If I didn't make this change, if I did not make the object a derivation of itself as far as the polymorphism settings, then I would have to not include the type variable in the JSON. And I don't like that because that is a prior knowledge exception. I have to know that that variable is of that type and to exclude the type definition in that circumstance. Is that likely to be an issue? No, but I don't like that kind of border case, like lurking in the shadows. So we fixed it. Do I like that you have to say that the thing is a derivation of itself? No. But it does let us say that if I have one of these, the thing itself is acceptable if you give this type declaration. Hooray. But this is the thing that lets us load all of our game data files. Okay. So that was something that we hung up on a little bit between the streams. And we found it because we are going to be, ideally, today working on how we load textures in. Previously, the only textures that we had, or at the time that our texture loading was initially defined, we only had sprites. Everything was effectively a sprite. That has long since not been true. Many of them are, but a lot of them are just a texture file. And what I will do with it is use case by use case. This is relevant because, let's find these here. Where did I put those? Texture wrappers. So some of this would just be kind of a hassle to have, but rotate to face, frame dimensions, loop animation, frame size, all of that is entirely sprite related. We don't need any of that other information if it's not a sprite. So I don't want to incorporate this, and there are a lot of things that just need a texture. So I don't necessarily want to define a whole class whose purpose is to just be a catalogable. Could I? Yes. And maybe we will, where we just have like accessor methods for dealing with the actual texture. But again, there are places where it just wants a texture, and I don't need to interact with that texture in any other scenario. Like, it will wrap the texture and do its own thing. So I want to get just textures into our data catalog. And then when we're dealing with a sprite, I will access it via the catalog. This accomplishes trimming down the data structures so that we don't have data structures where we don't need them. But additionally means that I have a better handle over Godot resources and where they're being loaded in. because a texture is an actual resource in Godot. It is a thing that isn't going to get duplicated. Once I've loaded that texture in, that texture is loaded. I can load it again, but I'll just get a copy of that same one, or a reference to that same one, kind of stuff. And we want that. But we also want to be able to find all of the relevant ones. This will become more useful when I start getting more of the shaders set up, because I don't want to be making extra shaders and loading data into extra shaders when I could just say, this is the one, this is the shader that I need for this texture, kind of stuff. Anywho. So, and while I'm at it, I changed the way I do logging. The catalog file reader previously had the only place that we did logging. I have made a static class for that, so that we have a place to write our various logs out. So I have a write to error log. I will have other things that are just regular old working. Oh. What kind of coding class are you taking, Adrian? The logger is very abstracted. Effectively, there are streamwriter mutex pairs. It's not terribly efficient to write to a log file as far as the code flow, because it is lock, open, close, unlock as far as the mutex is concerned. But if I'm going to be writing to file to have a real-time log, there is going to be a performance cost anyway. And since some of things like file reading are asynchronous, I need to have like mutexes and the like, things that are going to be thread controls. So it is what it is. But this lets me record this stuff. It gets recorded in... once you start having a log, it will make a folder for that day, and then each log file is defined by what the instant was, not really the instant, but the second level time it was when the log file was created, and then we record date and time within the log file. I'm trying to be as robust as I can with that, because once we start doing like actual gameplay testing, having to go in and try to find the code line where something started to get wonky without doing like line by line breaking would be painful. This will at least help us get an idea of where errors might be happening, as long as we incorporate a, maybe like an if debug kind of compilation marker. Game program and design, movement controls, and are on code into images. What languages or platform are you using, Adrian? Are you using like an engine? Are you doing like raw OpenGL or something like that? My first encounter with game programming was a very eccentric professor who wanted to get some modern stuff into the department, and what they ended up doing was it was the in C++ we did raw OpenGL. It was interesting. Hey there, Drew. Ah, okay. Okay. Well, that is another thing that doesn't get detected by my little my little chat programs and similar. So I kind of wish YouTube wasn't trying to pretend to be TikTok. But thanks for the high five, Drew. I appreciate it. I don't know what those translate into because that's like 2 levels of obfuscation away, but I believe they are the YouTube equivalent of bits. Hello, Ordinary. We are just getting started, folks. I am going over effectively what I have been doing since the last stream. We halted at the last stream because I didn't quite know exactly what I was going to be doing, and I have a better idea of that today. And stuff went down between then and now. So we have our new logger here. Just, what changed in here? Let me just double check. What did I... Don't need that. Leave those. Those are imports. Huh. Oh, okay. Just discard that. I don't mind removing extraneous white space like that. I don't like having it, but... I'm gonna have to see... I may go on a side project at some point and write another interface application into StreamerBot so that I can consolidate more of the handling, have a bit of an in-out kind of thing. Because at the moment, I have a lot of scripting in StreamerBot to handle all of my alerts and whatnot, and there are plenty of things that are clearly not handled yet. Sky is indeed quite fluffy. You can see the other should get a good view of... Oh, not quite. Might have to adjust that camera. The side of her head is mushed up against a pillowy step. Molly has the same general body shape that Sky does. She is smaller, but Molly is kind of chubby. It's not so much fluff as it is kind of pudge. Okay, so there's our type resolver. We're reading in. Error. It is going to be... Got to get this part in. To hide behind the dishwasher during thunderstorms. So, by the time I started streaming, he had already passed away, but I had, for a while, my first cats were a pair of Maine Coon brothers, Bob and Tom. Epic, I am putting in the last little bit here before we get into, well, we're working on our game, but I'm working on the last little bit before I jump into changing how we're loading textures, so I can try to get back around to displaying the map. we started down the design path of what the map display process was going to look like under the current vision. And we delayed, so we're looping back around to that. So he showed up on streams, but Tom, the one of the brothers, was just super sociable. He loved everybody and would hang out with like everybody. His brother, though, the one that had passed on before ever being visible on like a stream, was an absolute coward. Didn't matter, you know, cars passing on the road, thunderstorms, trains passing, aircraft passing overhead. Any loud noises at all would send him running. But he was a big Maine Coon. He took after his father, and his father was huge. I believe his father was approaching like 30 pounds. Just enormous muscle-bound cat. But yeah, Bob was a coward. He was a lovely little guy, but absolute coward. Okay, so let's see. Put the key in the message in there. So this error message happens if we fail to deserialize everything. So just a second here. Let's demonstrate that I haven't broken everything. Do that 2 waves. Data folder. Okay. So we have our text file open. I have a world map object here. This is a relatively vestigial object, but it still lingers. Here's the type definition that I mentioned before. I have intentionally misspelled it here. I've added an extra A. So this is an unrecognized type. It should not load correctly. Because we have it set up that unrecognized types should fail. So we get to the end, and now what we're going to do is we're going to hop back out here. Check our log files. We check today. Check here. Okay, so we have other problems going on, but this is the error line that I'm talking about here. So it doesn't know what that is. So that one doesn't deserialize. Now, we clearly have other problems that I need to validate that they're actually problems or not, but we'll see in a minute. So we'll just do that so it stops failing. Purge our logs folder here. So eventually I want to make it so that it will actually stop you from running if there is a problem loading the data. But for the time being, I'm just logging errors for it. And I am checking this because I have concerns. Okay. Not... implies the texture wrappers aren't being loaded. Yeah. Go to visuals. I know what might be going wrong, but we'll see in a moment. Let's see. Enemy visuals should be the one that contains that. Right. Okay, that should be getting triggered. Should be a file name load. So if we go into... Let's kill it there. Up into our JSON helpers, and it should be a texture name converter. Well, that would be if we load a actual texture wrapper. That is for the sprite. Hey there, Donald. Okay, so we're going to go into our rendering logic. Entity rendering, and this is node-based rendering, and then we have an entity visual sprite, which has a texture wrapper, which uses a catalogable name converter for a texture wrapper, which implies the presence of a texture wrapper. Welcome to having a large data pool to work from. Here we go, here we go. Data textures bullet sprite. Here we're getting... So what we should be seeing here is in this, we're saying so in defining this, we're saying that this should be a texture wrapper. And as part of that, it's going to say, it's going to run this, which is catalogable name converter, and it's using it as a type. Now, generally, what that would result in is here. This is going to flood me, though, but okay. Looking for sprite to come around again. It may not be apparent. The little red text here is the name of the object we're looking for. I'm just hopping along. I want to see it appear again. What this implies to me is that the textures aren't being loaded properly. So we take all of our files, and because we're not really sure which order that we're going to try to load something in, we essentially say that there are like, let's say there are 100 things, we will try to load our list of files 100 times, with the assertion that eventually you're going to get all of them. This is our name converter. If we look at loggables, do we have anything that is a texture wrapper here? Yes, okay. Textures are getting loaded. We are getting stuff in here. Oh. That's not right. That's not right. I know what's wrong. Yeah. There. I had it the other way around. So it spools up errors every time it tries to make a loop. If something doesn't work, it records the error for it. When it gets to the top of the loop, it says, okay, fresh slate. If we're done, if we are out of loops, and max loops is how many things there are, how many objects to parse there are. So if there are 100 things and I've tried 100 times, we give up. And this is running asynchronously, hooray. If we get to the end and we still have errors, essentially there are still things that have not been loaded, then we're going to spit out the errors. I had that wrong here. Instead of loading it into the pool of errors, I was just recording it every time, which is incorrect. Okay. Again, we've got our stuff loading. All of the stuff is still working. Enemies appear, all of that goodness. Now, we're moving towards the new map infrastructure. Part of that, the first part of that is we need to get those textures isolated so I can stop having to reference them as if they were a sprite when they're not sprites. Okay. So let's get some of this saved off here. Those there. Just doing a quick commit to the repo here. Okay. It's you and you. Just double check that our... Yeah. Right now I've just got it spitting out every file that it loads. It's doing that to the error log right now. Eventually that's just going to be if debugging is on kind of thing. It would record this, but otherwise the error log would only be written to if there was an actual problem. That is, regular logging, like generic, just everything is running smoothly logging, would only be in kind of debug mode Whereas error logs would always happen. They should never... You should never have one, so us recording if one actually happened is good. But this is the basic data load. These are all of our data files from our core set. So this would be something that always gets run. Hey, I am reading this file, this file, this file kind of stuff. Longer term, we are going to have, what would it be? Secondary folders. That's down the road, but I do want to make it so you can overwrite and add to the pool of things. You know, mods and what have you. Okay. So the next thing is going to be in our catalogable file, our catalog file reader, which I closed for some reason. File reader should be as part of the catalog. Yes. So we need a couple of things. We need handlers for the file reader needs to recognize, okay, I've got a PNG. And we will add that in here in a moment. Let's put it here. Here. As might be apparent, I really, really like extra white space when I am coding. So what we're going to say is that PNG files are okay to include. And then we'll need special handling for that. For reference, this is the handling for converting our spreadsheets into JSON. Every one of these lines gets converted into a JSON string. So there's... Hello, Ember. Hello. There is string shenanigans that occurs during this process, which we can see all of this here. So the JSON array strings, JSON strings, key value lines, properly wrapping things in quotes. It's also, it turns it into the exact same content that we would get if it was just a raw JSON object. Only reason I don't have all JSON objects is that there are a bunch of things that are just, it's the same thing over and over. They have the same column names. They have the same kind of values to them. I don't want to have a whole bunch of individual files that I have to scrape through and find all of those instances, as opposed to being able to open up a series of spreadsheets and say, change this column, everything in this column to that kind of stuff. Okay, let's see. This is our game data file where we are stripping through things. Here's our JSON file. Here's our file contents. I will need to trap and record this. We have not encountered this error yet, but I do need to. This is... if within a given load, so right now I'm loading the base game files. Inside the base game files, if I encounter a duplicate key, so like sprite 45. If I encounter two sprite 45s, the second one amounts to an override to the first one. But that should never happen. Instead, what we should be saying is like, okay, you can have an override, but it has to be in a subsequent like mod load. So this is recording, I have encountered a duplicate within the same code base, or the same mod. Within a given mod, there are two of the same name, and that's wrong. You can't have that kind of stuff. Together. View, because we don't want to be... We don't need to log that. That was as much testing. Our individual files. File contents currently is always assumed to be a string, but that's not right for this. So we have two different sets of files here. We want one that is all of our raw data files, which we are going to parse in this fashion. This is where we have our file contents and we want to load them in as catalogables. I want to incorporate the images in this too. So this is identifier and resultant string. And I would like this same process to be able to be handled. We can probably do this in sequence. So here. Right here, what we're saying is get all of the files in the supplied directory. What we'll do is then we call them down to, these are things that are allowed. These are suffixes or extensions on files that are allowed. If I say that I'm going to have two enumerations, one that is data files and one that is image files, where I'm going to have load catalogables for one pass of them that is image files, a load catalogable images or load textures or something like that. Then I will load the other ones. Yes. Because this sequence here is for data files, so our JSONs and our game data spreadsheets. But image files like PNGs are going to be different. Those we're loading in as their Godot resource kind of iterations. Okay, so this is in read file. So right here is for our data files, and then we're going to use PNG as our image format here. Okay, so this is... Okay, so this is all of the files in the subdirectories, unfiltered. We're going to call you data files. Which is that. So the data files are anything in the entire file pass that has a game data or a JSON extension. Then we'll have I will eventually replace this keyboard. Okay, and our image files are anything that has a PNG. So this is going to create something new here. When we load catalogables, we'll deserialize it, we'll get to the end, and then we're going to say add catalogable. There's going to be some extra things here. I could have a separate service that gets referenced for this, because we've created an implication here that everything in the catalog is a catalogable object. It makes sense. A lot of these are irrelevant now. This is also that type marker that we get when we're parsing the assembly for catalogables. This is where that type falls in. So here is when it starts, it loads up the data path. We're probably going to end up changing a lot of this where we will be able to call loading in like a different sequence, essentially. We'll see how this goes. Here is the override process. If you overwrite something, you overwrite it. But anyway, we'll cross the modding bridge when we actually get the base game fully covered. We're just setting it up so we have the option to go down that road without having to rip up the floorboards. So we could have a core static that is just always there. It loads up fixed resources. But those resources are going to be part of the different file sets. So I think it does need to be part of the catalog. Okay. I declare it to be. String to a texture 2D. What are we using in our logger? Using system.threading. Where did I have that elsewhere? There we go. Godot has a lot of things that the base C# stuff already has, since the Godot side of it has its own implementations of those. Not thrilled with that, but here we are. All right, so for our catalog, our base type, we need we ever do this anymore? I'm pretty sure we don't do this anymore. Historical reference. There was a period where we were attempting to do all of our rendering of entities inside of a truly monstrous shader. And part of doing that was that all of the textures that we were using were stitched together and loaded into that master shader. But to do that, we had to get all of the keys. Hey, Drew. We're doing pretty good. We're doing pretty good. Hydration reminder. That is a good point. We also have a lot of these get this very specific thing calls that I don't believe we're actually using anywhere. Yeah, we have a couple of places where we use them specifically, but they are vestigial. Real quickly, though, I want to not forget to take my hourly breaks here. I'm going to get up and move around a little bit. I will be back in just a couple minutes. Okay. Those breaks are good opportunities for me to get the exercises I am supposed to do in a little bit at a time, you know. Otherwise, it's so easy to forget, and then you haven't done them in a while, and if... Anywho. Okay. Catalogable. We won't be copying catalogable in this case. We are going to... Ma'am. 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 Ember has come to sit with me. I had the audacity to get up and move around. So she moved to shadow me at every opportunity as I moved around. Like, cats burn hot. I mean, they are toasty little critters. It's the kind of nature of metabolism, you know. But you can really tell when it's like a smaller cat versus a larger cat, because the heat that a small cat can put off tends to be concentrated a little more closely. So, like, when Ember lays against my shoulder, it is super toasty. What? See how much of this little troublemaker you can see. We're getting the slow S-curve tail undulation there, but when Ember is like real excited, she practically wags her tail. Are you done? All right. And add catalogable gets a catalogable, so we are going to say texture 2D. Then over in the actual catalog where we add catalogable, to override. That needs a key. Typing. Okay, so it's the same sequence here that we're dealing with. We have, when it's a catalogable and we're adding it, we just pass it in because the catalogable has a name with it. Again, we could wrap textures in this. That is still an option for us to do, since it would then make them all catalogables and I don't have to deal with special handling. But should we? Because that would make the existing texture wrapper a texture wrapper, and it has no other function other than to supply things like the key of it. But I don't think we need that. Because a texture has its name. I can keep the name of the file consistent in that regard. Alternately, I would have to define... Yeah, no matter what, it's still just going to have that fixed name. So, yeah, that'll do. That'll do. So this creates a collection of textures. We're going to do an interim here. This is prep for the texture load. Okay. But another thing that we're going to do here is we are going to scrap use cases that we don't need anymore. Because most of these things are going to be assumed. So with get catalogable, I could update this thing so that it is a template method so that I wouldn't have to constantly cast them to a type. In theory, but we'll see. We'll leave that. But it's these get individual ones that aren't really useful. So get entity, we have one spot where we're actually doing that. So if we change this to get catalogable, it should still run, he said. Yep. Okay, so we record that. Now, I may circle back around and make an interface that is very explicit about what you're requesting from it. But for the time being, we're not going to do that just yet. Because all of these were just forcing the key. Get catalogable, force it to a type, and return it. That's fine, but it means that I'm constantly making new methods here, and we're just going to not do that. So we are hunting those down so that I can rip those out for the time being. Copy is fine. Instantiate copy is fine. Add is fine. Okay, so then we are going to pull all of this out. Same thing with here. These have no references. So we build again and we run and we make sure I didn't blow something up accidentally. Okay. Push all of that so I don't forget. Okay, so now we have a way to add textures. Get a get for a texture. Could bother me, and I will fix it shortly, but it's not a void, it's going to be a texture 2D. And here and to texture. No. So we're always going to get something out of this one way or another. Now, when we do a catalogable, we create a copy of it so that we're always using the prior as a template. With textures, that's not how it happens. Yep. Okay. So we now have a means of adding and retrieving textures from the catalog. It's in there. Okay. Then when we're doing our file read, we have our concept of load catalogables, but now we are going to have here. Don't know why that was a public method. Okay. All right, let's think through this one. This is going to have a for consistency. That's syntax. Run. Not the biggest fan of lambdas, but useful in this scenario. Success. False. This is still going to be a if. Not count length. Hey, Zell. Welcome. Technically not ideal because we are altering this collection after we have it. Hey, Starlet. Welcome. I may not recognize you because YouTube is using the @ handles instead of the screen names. So are they still doing that? I can't tell. Yes, they're still doing that. For reasons. I want to do this. This seems wrong. We're iterating over the collection of keys, but we're altering the collection of keys as we go. This seems problematic. And I think it might explain why one of the... All right, so in setting up how we're going to load the textures, I have discovered that there's something questionable, shocking, I know, about how I am piecing this apart. So inside this loop, we have our main do while. But in each cycle of the do while, we're going to go over all of the keys in catalogable here. We shouldn't be messing with the keys in this loop. We should assert... We should have a collection of keys to remove. Ideally, we would duplicate this dictionary coming in and not mess with it. Yeah, right here. Create a collection of keys and iterate over the keys. So these are... There's going to be two things that we deal with here. Is we have a list that we still need to parse. So the collection of keys still left. So I'm gonna clear a hair out of the mouse here. Cat fluff in the sensors on hardware of all kinds is a perpetual battle. Ring. And let's see how many. Should have like an enumerable. Yeah, okay. Can this create a problem? Yes, it can. But dictionaries should not have duplicates, so shouldn't actually have an issue. So in each part of the loop, we're going to have a... Okay, so right here we're going to say keys to remove add key. Then we get all the way down to the end of this do while here. We have keys to parse. For each one of those, keys to parse, remove key. Okay, so it comes in and says, get me all of the keys in the catalogables to parse. So those are our keys that we're going to be running through. It's hitting the wrong key there. So we're sending this async. We're going to wait on this to run, and we create a list of them. And say these are the keys that we actually got done with, that we actually processed in this loop. So we're going to go over all of the keys in keys to parse. We try to load it. We're still getting our catalogable from our catalogables to parse. And if we actually if we don't get a result when we try to deserialize, we're going to log this error for this loop. But if we do, we are going to load that catalogable to the service here. And then we are going to queue that key for removal. So we've iterated over all of our current keys. Now we're going to remove anywhere we found something in our keys to parse. And if keys to parse is empty, then we're done. Okay, did I break this or no? Didn't break. Let's double check. Yep, okay. Run that again just to be sure. Okay, good. So we were doing two bad things there. One, we were passing in a collection saying load these, but as part of loading those, we were editing that collection. Can you do that? Yes, but you need to make that pattern very clear, because otherwise you can have, hey, I'm going to use this collection 2 times in a row, but if I pass it into this function, that collection is essentially destroyed as a result. We are no longer doing that, and we're also not changing the collection inside of a loop that was iterating over it. I'm ultimately surprised that it didn't explode on us, but I have a feeling that we might have just lucked out on the regular. Okay, so the nice thing about load textures is we don't have to worry about the dependency layering here. It's if a texture is loaded, it is loaded. Full stop. Files. Okay, so we want to take the texture, we want to load it from file. So that we should have a pattern for that already in our texture name converter, I believe. Yes. We load the image from file, and if there is an image, we will create from image. Texture 2D. Okay, so for each of the files, we're going to iterate over and we're going to say, all right, prep the variable, if this file exists. File not found. You know what? If the file exists, then we should be able to load it from file. It's probably going to be flaky if I get the wrong file there, but... To get this far, it has to be a PNG file. And the file has to exist to get this far. I think we're okay there. So here we have a texture. The texture isn't null at this point. Going to do this pattern. We are going to return a result in this, and we are presuming that it worked I don't really like that we presumed that it worked. We don't want to just stop, but we want to record an error for each one that doesn't load. And once it doesn't load, we can cascade from there. But ideally, we would just stop if an image that needs to be there has a problem, because that will ripple up. It's if something doesn't load properly, like it fails, then we're going to get an exception elsewhere, and we might as well head it off. All right. Or adjust in chair. Ugh. Freak. And is less than files dot length plus L is equal to files I. Okay. Actually, we don't need to just stop. Yeah, we don't. Okay. Okay. We've ultimately just renamed success, but we're being clear about it. It's if any fail, then it did not succeed. It's not ideal in this structure, because if anything about this crashes or bails out sooner, then it will go out of there. But that will probably result in another exception, and is generally a worse case than just there was a problem loading textures. It's path, actually. name without extension, file. Okay, so if we get a texture, then its name is the name of the file without extension. Otherwise, we're going to need that name by here. This is logger dot log error. Sign string. There's a good way for me to come up with that. And you could use a string builder for that, where you specify parameters, but for the time being, we'll just compose them. Okay, if any of the textures couldn't load, we would get this error here. Hello, Sky. Come sit with me? Yeah. Maybe once a stream, Sky will come sit with me. And if he does, that means he wants a lot of attention. He wants his full back scratched, maybe his chin scratched a bit, ears. The whole deal, and you can't stop. Because if you stop, he'll climb up and headbutt you. Or he will do that nice little, oh, I'm going to rub my chin against yours, but Sky has really big canine teeth. So when he does that, he rakes that tooth right across you. Doesn't break the skin, but it hurts. In that right. In that right. Yeah, troublemaker. Okay. So now, if we go into our file reader, we need to call load textures on the rest of it. So there's our load catalogables. Here's our read files. Now we have our image files here. Okay. File access is, it's probably system.io. Okay. Look at our log files. No errors were logged. Textures are all still loaded. Okay, let's go. Okay, so we need catalog, textures. Yeah. So now the next thing will be when we're loading them, we're no longer going to load textures by file inside of our setup for things like texture wrappers. We're going to load them by identifier. Now, one of the advantages of doing this... Hey, Laura, welcome back. One of the advantages of loading textures like this to where they're not... This file in particular matches this particular object. It's that we're going to be able to build things like atlases. So I could have like one big texture of all of the heart graphics. And I can come up with a syntax that is, okay, use this texture as a atlas texture. And then when I'm referencing hearts, I mean this cell in the atlas texture. And that would give me a usable texture reference to use on an object. Which is more efficient than having a single texture for all of these things. Oh, well, thank you for the follow, Hyperbagel. Welcome, welcome. No offense intended, but I always like to ask about stream handles. Is this a hyperbagel in the sense of a very big bagel, or a very fast-moving bagel in the sense of like hyperspeed? Or just emphatically more bagel? Like bagel extreme? Don't feel like you need to answer. Well, that's as valid a reason as anything, Hyperbagel. But again, welcome, welcome. Okay, they're all in there, so now we need to change all of our texture wrappers and our handling for it to retrieve a texture name. Or to retrieve it by name. Okay. So now our texture name converter and our texture name list converter, these are very similar to catalogables, but not quite. So it's no longer about texture file paths. It is... It is a key that it's getting. And we're going to get it from the catalog. So that's our texture key. We're not going to... catalog.get texture key. Most of my stuff can't actually be serialized. It's not plausible to actually serialize it. But it's never really the intent that we would do that. I don't know if I can purge those as a result, but anyhow. Make sure we get a texture key. And then it is equal to services catalog texture key. Check texture name converter. Bit of redundancy in this code. Not thrilled. Okay, so this should cause some havoc here. It's just spinning. I don't know. Shouldn't be able to run this long. I broke this. Try that again. Let's see where it's breaking down. All of these should be failing, is the thing. In what? Still in load catalogables. Seven. Okay, so it's iterating over all of these, and it still hasn't gotten any of them. We do need to have something that if it loops and it doesn't change. So if the end of a loop comes around and we have not decreased the size of keys to parse, then we have a problem. We immediately have a problem if we're loading these and none of them loaded in a full pass. Because again, this is, if the textures don't load, the texture wrappers can't load. If the texture wrappers can't load, the visuals can't load. If the visuals can't load, there are no sprites or no bullets, no enemies, nothing like that can load. So maybe some of the things will get through, but we'll reach a point where it just can't work. Okay, it's in the declaration of the loop here. Okay, so we get to the end here and we remove all of them. If nothing was removed, we're going to break out of the loop. Yep, which we will now air. Yep. Okie doke. Too many changes in this at once, but so the way the load happens is a constant iteration. Is we'll get like 100 objects to load, but some of those objects might depend on arbitrary other objects in the list. And since we're not like defining a hard order to load these things in, we just say, okay, try to load everything. And if we do that often enough, it'll kind of, the dust will settle, you know? with each pass, more and more things get loaded. If there is ever a pass where nothing got loaded, that means that there is some dependency that exists or some failure that's happening that will prevent everything from loading. So if that happens, if we never remove a key from the things to load, we are never going to remove a key from the things to load, and nothing will ever load. So just stop. Again, we don't have a universal bailout that says we couldn't load the game, you're done, don't try to run the game. But eventually we will. Okay, so now all of these places where we say texture here, instead, what we are going to do is change them to that. We're going to need to do this in a whole bunch of places, but happily, shouldn't be too many. Because all of the places where this should be happening are in things like Sprite and similar spots. Yeah, where we're setting up textures. So here are all the errors that we were generating. Data, okay. Bullet visuals, same way. Textures. Again, one of the advantages of changing this around is that we're going to be able to alter how we treat a source texture. So this is a raw texture, and some things will use that. So, I'd feed it to a shader or stuff like that. But I can also have sub-entities later on, like classes later on, that wrap these. So this is one of the examples of why I don't like that I was treating them all as sprites. This is not animation. These are for animation. But I could go in and say, okay, these are Atlas textures. How do I get one? Well, I wrap it up like that and say, it's Atlas texture 5. It still treats it as a texture wrapper, but when you ask to get the texture, you will get the piece of the texture that matters. That kind of thing. Okay, icons. I am going to need to add some debugging tools for things like find already used keys. So something that would search through the first column in all game data files and similar. Hey there, Doomed. Welcome and thank you. Thank you. You have arrived in time for the let's edit some spreadsheet columns portion of my game dev process. It works with our existing music, but I feel like for situations like this, I need something like really intense to switch the soundtrack to. Just maximize the cognitive dissonance, you know? So again, what we're doing right now is we are changing the way that we load textures in. And we're saying that this file, we load the texture in by its file path, and we give it an identifier that matches the file name. Subsequently, when we need that texture, we identify it by that name, and we retrieve that reference to it. Yeah, this will be more useful for other Godot level variables, but we're building upon the pattern here. Yeah, unrelated to the game dev at the moment. We've got a bunch of... Okay, that's a dead file. We've got a bunch of games on the horizon that I want to get to. It's not there yet. The third installment, and apparently the final installment in the Amanda the Adventurer games, has dropped. Collision gates, there are sprites. Map test, and we're referencing this. So we need to do the same thing here. It's when you deserialize a texture wrapper object. We are pulling that by texture name. Okay, sorry. Keep that tab. Oh, go into our logs folder. We're going to get our next error log here, almost certainly. Okay. In level test, world map _ test not found. There we go. Nice. Okay, did this have a big impact? Not in any way you can see, but in the background in the code, we have fundamentally altered how we are treating textures here. It means that we can go in and we can now start setting up different ways of interpreting those textures. Like, this part of this texture means this thing. Because you're so we have our room test here. This is a single instance of the texture. What we want to be able to have is a whole bunch of these in one texture and be able to define this spot on this texture is this thing. Then when we're loading up a level, we might say, okay, this level, this room is on this texture in this spot with these dimensions kind of thing. So we are going to need to look at some stuff here. Okay, where is our test bed? You anymore? Boop. What do we need here? If we use a texture edit is a texture rectangle. Okay. Atlas texture. Atlas texture needs an atlas, which is going to be a just be an image texture. Yep. Let's do a test on this here. There it is. You. Gonna need to figure out how we want to play with this. Okay, so this is how it would end up being. So let's... So this is me defining the region in the texture. So we're saying for this texture, so this is a texture which is a texture atlas type. So let's stretch it so you can really see it. I've defined it as a atlas texture. And within that atlas texture, we're saying, what is the source image? So this whole tile sheet that I gave it. This little guy right here. Then I tell it the region that you're dealing with is these dimensions. So it's 16 wide by 64 tall, which is this. Okay, if you look right here, it's by my right ear. That is what that space looks like, and then we are using that for the texture that we're painting on this, which is stretched to fit at the moment. It wouldn't have to, but this means that we can have a wrapper for a texture and say that this is actually an atlas texture that we're loading, and break it apart into multiple pieces and have them say, when I get this texture, this is the part that I actually need, is this atlas texture. So I could have a data file that says, when I'm parsing this, I don't actually mean to load this raw texture in its normal format. Instead, I will create a series of entries in the file that say, this is the atlas texture. Like, this is the texture that we're loading. This is the piece of it. This is the piece of it. So, I can have so like this is, grid cell 1, and then I can move along and say this is grid cell 2 and 3 and B48, and 4 and 5 and so on, is I can define each of those based entirely on which position and which dimensions to use. And create that accordingly. We can go in and we could define this region however we want if we were using the Godot editor, but we're not gonna. If there's anything else we want to mess with up front. So, the reason that this kind of thing matters when you're using an atlas texture is I am not loading a 16 by 16 thing for every one of these tiles. I am loading one file. This one file is in memory, and now I am creating kind of pointers to, or little pins on that one, and say, when I refer to this one, I mean this part of this texture. It's more efficient for the system to do that within many constraints. But in general, having one texture with lots of things in it is easier for the system to deal with than having many, many, many little textures. This opens a lot of just general doors for us, because now I can say, take this whole set and create like a master for it. Define all of these as part of a bigger one. We will probably get around to doing that later. That is amongst the things that what I would like to do is have, here are all of these files and their names. Have a part of the process that would go through and create that meta file, that Atlas textures load kind of concept that would then say, using this texture, I am going to create a series of Atlas textures that have the corresponding names. And have those loaded in. But we would have to come up with a way that would dodge like name overlap kind of stuff. Okay. Now... next, what we want to do is get the map loading in there so that we can get that texture into the process. We're getting there. We're getting there. I'm in a kind of a, well, what do I do first? Because I'm feeling like I want to create a wrapper around generating Atlas textures. Right now I have take all of these PNGs and load them as individuals based on their file names. But I would kind of like a way to, instead of doing it just that way, to have a structure for reading in the textures and how they will be broken down. So it wouldn't be like... I kind of like the idea of just dropping the textures in. That's fine. It's how do I define them individually to make it work? Because what I'd really like to be able to do is have a pre-process step where I have a name for it defined. I know what it's going to be called. So I will then take that texture and replace it with the corresponding Atlas texture. But we may just be getting way ahead of ourselves here. We are going to want to have this because we are going to want to be able to efficiently load levels and corresponding room objects. But I think if we just start with the texture, then that's at least where we can kick off from. So we're going to change our map renderer to, instead of loading the level... oh, it was. We're going to load it as an image, which puts us back in the territory of the shader renderer. So let's go find that little guy. We may need that again later, but there's nothing stopping us from just recreating that. The testbed scene is where I just mess with the Godot objects, because messing with the Godot objects in the editor can be easier for exploring how it works and make it so that you can use those inspector names to find the corresponding C# code side names for interacting with them. Okay, so then we're going to go into our rendering logic for the map, and we have our shader-based map shader, our map shader renderer. So this is the thing that we essentially would create an entire grid process on the shader, and we would load the whole visible map to it. But there are a couple of things that I want to try to do, and that's, one, create our shader materials and get them fully prepped for use. Like, how do we scale it, all of that kind of stuff, and get it ready so that we can then reuse it, because the textures that we're going to load to it and how we will deal with that are things that aren't going to change constantly. Effectively, we would have the room shader. We could even have shaders for each of the different rooms and similar prepped up. And since they're never drawing, they're never running any calculations on the GPU, but they're ready to go. So I would have my Atlas texture saying, this is the actual texture that you're dealing with. I have put it another way. So we have where we're drawing to. Various elements of where we're drawing to. And we use the shader to determine where we draw. We have a series of rectangles that we're creating and painting around to indicate where we are in the world. I'd like to mitigate as much of that as possible. So we create an image where, given its properties, it is deterministic what it paints. As in, it's 100%, this is the value in, it will always produce these results based on those values. So it would just be in the material. This is older code. It's been a bit since we've touched it. So there's going to be a heavy rewrite on this. Just going to read through the shader code for a moment and try to remember what we were doing. So, for reference, this is a fragment shader. It is done as a part of a canvas item. This is a 2D texture shader. So for each pixel of that shader, we are going to map that pixel of the thing that we're showing. So on the screen, the map that we're rendering, we're saying for each one of those pixels, which pixel on the actual map image are you looking at? And when we've got the map texture laid out, what we would want to do is say, okay, this texture is this big. It is 400 pixels wide. It'd be way bigger than that, but it's 400 pixels wide by 400 pixels tall. So each one of those pixels is going to be mapped onto the square that we've got. We are going to take the UV value, which is the spot on the rectangle, the spot on the shape that it's pointing at, and we're getting the corresponding color from the given texture. So this should just be a one-to-one process. And it will ultimately depend on what we can get away with. Like, can I just take the entire map texture, or do I need to slice it up? Do I need to say, given my offset, given my view box, you know, where am I in relation to the origin of it? Because if it's where am I in relation to it, then I need to have potentially multiple of them there. We do. move around a little bit. I will be right back. Okay. All right, so looping way back around to last time's design thoughts. We're breaking the game world up into rooms. Rooms are of arbitrary size. Think of old school Zelda, Binding of Isaac, any of those where you enter a room and that is where we determine like how you can exit, how you where you appear, how you exit, what you'll be facing in that room, kind of stuff. But again, room is an arbitrary concept. It need not be a indoors thing, anything like that. It's just a kind of a scene within the game. So we have options for how to present that. Now we can say the scene is rendered either by calculating how many chunks of room there are to deal with, and offsetting it accordingly. So we could create a series of kind of viewports to put up there. We can just declare that rooms are only so big, kind of thing. thou shalt not make a room that has more than 4096 by 4096 pixels, which I think is reasonable. And that might be where we start. And we can double back and add complexity when we get there. Let's start with that. Okay. Scaling factor is 3 now. We'll have to update that. Creating our shader material, we prepare a shader for it where we are loading in our map shader renderer here. Create the visible area. Setting it to anchor on the top and left. We give it the shader material. Tell it its scaling factor. Where do we use that in here? So I want to get to this part. I do want to get to the part where we're just rendering this stuff as efficiently as possible. But from a practical perspective, we're not even doing tiles right now. We're just saying, this is the part of the world you can see. So we could just plonk the whole texture down and not deal with a shader right now. Which gives us the advantage of we could load all of the rooms in as textures by themselves, spaced out such that you can never see one from the other, and just have them as free-floating areas. We'll need to deal with the only simulating the entities relevant to that particular area issue. Like encapsulating entities so that they don't get updates when they are in a room that isn't active anymore. But that's as much a later thing too. Okay, we'll loop back around to shader based. Don't even load map chunks anymore. Is our override? Mask. Set world map. And handle message. We are. It is quite likely that the map renderer is going to get heavily refactored soon. Beverage. So with all of these little bits, these services, it's not really the right word to use for some of these, but they're effectively plugins that I'm writing into my game that let me swap pieces in and out as I'm doing the development. It's largely as I am moving from one idea to the next, it gives me an opportunity to experiment for a while before I decide to really go all in and swap it over. And it doesn't require me to go in and edit a bunch of places that were referencing the old pattern and are now referencing the new pattern. It's you interact with a map renderer like a map renderer, and if I swap out which one it is, you don't have to worry about it. And which one it is defined as part of the startup process in Godot. There's a resource file. There's all kinds of little things that I do to facilitate it. But for the time being, that is... Let's see. Switch chunk to load. We're not even doing the chunk stuff anymore. Hey, we just override set world map. Set world map. Message. Game message reply is effectively saying whether the message was like, did you do anything with it? Should it go away? Should it continue along? Those kind of things. Things that send the message might care about that. And the whole logic behind passing the message along cares about that. but for the most part, most things will just say when they get a message are like, oh yeah, sure, I looked at it, you know. Okay, when we set the world map, that's when we're going to add some stuff. So for experimentation purposes, we are going to create a texture rectangle that is the size of the texture that gets loaded in with the world map. Ew. I don't know what the trigger point for Sammy was, but Sammy has gotten downright snuggly in the last month or so. She has realized that she quite enjoys climbing up on my shoulder. Previously, so Ember was the first that does that, that did that. Ember, as far as like climbing up on my shoulder. So Ember did that first. Then Mason saw Ember do that, and I don't think Mason understands like kind of the logistics of that process. So he'll walk over onto my lap and he'll kind of walk up my shoulder with his forepaws, rest his chest on my shoulder, and then he just kind of stands there staring into the distance. Or he'll climb up a little bit and I will try to hold him there, and then he will he'll sit there for a moment and be like, well, I don't really like this, and he'll get up and leave. And then he'll circle back around and try to do it again, with the impression that, well, Ember really seems to like this, and I just don't understand, but I'm willing to try repeatedly. And Molly will sit on my lap, and Sky will sometimes sit on my lap. Many of the cats have been willing to like sit on my lap briefly. And Sammy was well, I'll be on your lap very briefly. But now she has decided that my left shoulder is quite favorable to her, and she demands the sort of attention that Ember does when that happens. It's just fun watching their behaviors evolve over time. Like, it just struck Sammy to try that out, and she's like, well, I rather like this. It's extra fun when Ember and Sammy both try to do that, because normally they're not like aggressive towards each other. Sammy and Ember pretty much get along, but there's a real kind of personal space vibe between them. Ember is usually the first one to get up and move if somebody gets in her space, but that particular case, you can tell if Ember is getting attention on my right shoulder, where she likes to be, but Sammy wants to get on my left shoulder. They kind of wait it out and see who gives up first. This guy is demanding chin scratches. You should be able to see like half to a third of him once the camera loads here. Yeah, about the back third to half there. Yeah, more of the back, more like the back third. Kind of hard to say. The only the back part of the white stripe on his back is visible there, so mostly floof. Yeah, an Internet of Things controlled door lock is wrong on so many levels. So the cat cameras are all power over Ethernet, non-wireless cameras. They're not connected to the internet at all. And as far as like readily available, like easy to find for, let's say, home use, you know, those are not common. What you'll normally get is fully Wi-Fi, 100% app controlled, third-party live service kind of BS. Like, they only work if they can connect to the internet. They will shut themselves down if they can't, and they do all of their traffic through a remote web server. It is all of the privacy violations, none of the convenience. I managed to find Wi-Fi cameras that were still at least not phone home machines, but they were finally starting to die out. A lot of them were starting to malfunction. One of the advantages of the PoE style cameras is that there are a lot fewer moving parts. These are just fixed direction security cams. They have all of the perks of the prior ones, assuming you can get the network cable run to them and you have a powered hub. This guy's flopped onto his side here. So his positioning right now. So that's most of Sky that you can see there. Just not the entirety of the front shoulders and head, you know. So you can just barely see it in the upper left-hand corner there, but his forepaws are against a draft excluder, which is part of the keep the cats off my mouse and keyboard operation going on here. But when Sky wants attention, he will be like right there. And his head, for reference, is if he were to lay his head straight down, he would have the top of his head right next to my mouse. And when he's in a position like that, if he doesn't get the attention that he wants, he'll just flip his paw over and grab the mouse. And you know, you don't want to attribute too much specific thought to an animal, but I am confident Sky knows that moving the mouse and pressing the buttons on the mouse accelerate the rate at which he will get attention from me. Like if he's sitting here wanting attention like this and I don't give it to him, he will periodically whip a paw out and smack the top of the mouse or grab it and pull it. It is a less destructive version of some of the things he will do, but no less disruptive. Are you done or what? No? Okay. The interruption by cat portion of the stream. Let's take advantage of that. Let's look at the others. We should have... Okay, so we have Ember by her lonesome up in the tree there. We have Sherbet across from the keyboard. Part of the reason that Ember is up there is almost certainly because Sherbet is where he is. He is in her spot. And Ember is very low confrontation, so she will just go somewhere else and pout, usually. Sky on the side, as mentioned. We have Mason there on the bed. And we have Sammy getting some food. Now the question is, where is Molly right now? So one of Molly's favorite spots, and it makes me very paranoid, is that she likes to lay right beneath my feet right next to the wheels of the desk chair. And she is clumsy and unaware, so she has, while she hasn't gotten anything squished, she has managed to get like her tail fur pinched under a wheel, and she won't notice until she finally decides she wants to go get some food, and then she will notice, hey, wait, my tail is stuck. So frequently I have to lean around and check with my feet and see, is Molly beneath, too close to the wheels. Oh, yeah, I know, Sky. I know. See him shifting his paws. He is leaning into my fingers here. His brain is itchy, it would seem. What? What? Come here. Sammy was crying, and so having called out to her, Ember has played the no me card there. Come here, you. Come on, yeah. It's not one, it's one of the others. Well, now typing is completely out of the question. Ember climbed up on my shoulder, and Sky kind of drooped a bit and laid his head on the mouse, so the right hand is devoted to Sky, and the left hand is holding Ember against my shoulder. It's an adorable, fluffy problem that I must deal with at the moment. All right, so mechanically what we're going to do with the room renderer right now is that we're going to start with just creating a single texture. We're going to take that world map and we're going to take the texture off of it. We are going to measure that texture, and we're going to create a texture rectangle of the corresponding size and slap it on the map and see what happens. On this more, there's definitely layers that I want to set up. I think that might be an element that I work on, is figuring out a way to generate Atlas textures so that I can correspondingly reference them instead of the other way around. Oh, look at that little foot kick there. You big floof. You big floof. Let's see. We are just going to attach a child. So we're going to make a texture rectangle. very slowly typing here. Texture. Okay. Render is a Node 2D. So then we have to go into the Godot side. And we need to add a scene for our map renderer. Node 2D. We are going to attach a script to it, which is okay. Then we need to go into our resources file. Startup resources, default startup resources. This is that thing that I was talking about a moment ago, the ability to swap things out. We are going to now change how I render maps. Map render. Boop. Okay. That one. Hello, Sammy. Everybody else getting a turn and you want a turn? Know what this is? Yeah. Sammy is my shoutiest cat. So of all of them, she is the one that will just, look at you and meow like regular old meow. Generally quite loudly. There you go. Yeah. So whereas Ember is very light and, can be easily held in one hand up against my shoulder and like stroke her back. Essentially cradle her just above her hips. Sammy, that is not an option. Sammy must be braced on one arm and then pet with the other. Just so. Yeah, otherwise she'll yell at me. So this is me reaching for the mouse, and she immediately stops and like rolls her head to look at me. Like, hey, you stopped. I know. Sherbet will be nearby. So for quite a while, I referred to Sammy as the tsundere princess. She was an arm's length cat, and she would want periodically to get like a brief head pat, you know. But she wouldn't want you to get too close to her or anything like that. But she would be waiting at the steps or something like that to yell at me if I was gone for too long. Sherbet isn't quite there yet. He is right across from my keyboard right now. He is still definitely an arm's length cat, but you can tell that there is a... like, he's very interested in me knowing that he's within reach in case, you know, he should happen to like a back scratch right now. Or to inform me that, you know, it's really late and we should head towards the bed, because then I might happen to get back scratches on the cat tree by the window. He will also lurk nearby and just stare at me for a protracted period if the food dishes are empty. What? He has become quite jealous. Okay, so, but what we saw there is that the scaling did indeed work. So let's... I know, baby. I know. Oh, yeah. Very, very slowly type. Startup resource. Scaling factor. What? I'm being scolded. If it weren't for the fact there's a lot of things like fans and residual noises and whatnot in the area, I would turn off the filter on the microphone so that you could hear my cats shout at me. If only there was a toggle for "but include cats" in the voice filtering. I generally have, let's say, low tolerance when there is something like, you know, an air conditioner aimed right at somebody's microphone. Because there are tools available to mitigate that. Now, you know, if you're playing on console or something like that, you can get away with some of it because that's not always like a built-in feature. Though at that point, it's kind of inexcusable that the console developer didn't make it a built-in feature on the microphone to run the basic noise filters. Yeah. I'm not even allowed to try to hunt and peck type at the moment, or else I shall be scolded by Sammy. Yeah. Uh-huh. Sammy is also one of the two that greatly dislikes having her nails trimmed. Sherbet is the other. the one on the camera right now. With him, it's exceptionally difficult. He is still likely to draw blood if I try. It is a very careful operation. Sammy will dislike it a lot, and there is a time limit before she's so uncomfortable that she starts to kind of fight. It's the let my paws go right now moment. But I can usually get a couple of them clipped before she gets to that point. With Sherbet, it's an operation, like I said. Last time he only got the meat of my palm and like a few slices across the belly, and I got both forepaws in exchange. I feel like that was a pretty good victory. When I first tried to trim Sammy's claws, I was bandaged to the elbow, including a couple of bites on my palm. So, and I did not get any paws trimmed. So, progress has been made. Generally, I don't need to trim them a lot. There's every now and then you get kind of a sweet spot where the claws kind of grow blunt over time just by how it ends up. But you're just as likely that while they're grooming, that the claw fully grows out again, and so you have that horrible needle that forms. And while Sammy is getting, ear scratches and whatnot, she's all snuggled in, she flexes a paw, and I become very aware of all of the claws that aren't trimmed. But if you wait too long, or if they grow out for too long, they will get... It's fully hardened at that point. So, like, you can really tell the difference when it is a fully developed claw that they're just actively sharpening instead of a claw that is regularly trimmed back. If nothing else, it's a very tactile difference. Vector 2. Again, just proof of concept. Nice. That's about right. So then the next thing would be... And we can just load the texture. If we're going to deal with the whole texture, then we might as well deal with the whole texture. Just doing it... If we load it in as part of the shader, we still have to have that whole thing in memory and render it that way. So I don't think we're going to save anything by having multiple of them. Okay. So we now have it rendering using the room renderer. Hooray. Let's make sure we don't miss anything here. Discard those changes for that one. Don't need the changes on that one. And texture references. Room render. Use room render. Okay. Think. All right, well, let's load the other map image here. So it should be rooms test 01 that we want. Math isn't quite right as far as how I scaled it, but actually just about spot on. Yeah. There you go. That is a full screen. Hello, Molly. I mentioned that Molly likes to be under my feet. Okay. So all we're doing with this is that we're saying the screen is anchored at 0, 0. That's where the texture is right now. So a room has a position that is the upper left position of it. Then we need to create a boundary around it. So we're going to get the dimensions of the texture here. And we'll create some... Each room will have collision regions on it. And those collision regions are the you have touched a wall. So when we're creating one of these, what's it called? We should have something in the collision handler. Okay, we make a collision shape 2D. We make a... So we have an area 2D. Entity area is just an area 2D. So we need an area 2D, and then we need a collision shape 2D. So we won't actually put the collision in here. We will have a room object as part of the world state. This is just the logic for saying this room exists, and how to draw it. So kind of hacky at the moment. Hey, Lunar. An Atomic Wasteland DLC where it's Mad Max meets Fallout. I mean, forgive me if I'm wrong, but isn't Fallout doesn't the original Fallout take heavy inspiration from Mad Max? Thought one of the default outfits, like the leather armor that you could get very early in Fallout 2, was Mad Max's outfit in the second movie. I suspect the only reason there aren't roaming bands of gangs and tricked out cars in the Fallout games is because, well, you know, once they moved to a level of technology where that would even be an option, they just sort of took a path that would prevent that. So again, it's very I like the narrative convenience of why cars don't work in the Fallout worlds. Where it's just like, oh no, they don't. Well, why not? Because we've never figured out a way to make them drive around. And Bethesda certainly isn't going to be the ones to do that. Okay, so we have an area that is the collision. We have a shape to go with it, or a collision shape, which is defined by the actual shape that you give it. We use collision shape. Well, that's that weird aspect, Lunar. So you have things like in Fallout 2, one of the core mechanics was you drove a car around. Now, Fallout 2 into later ones is sort of a canonical split. Some of the elements carry forward, some don't, such as cars what work go away after Fallout 2. Sort of. Again, now we have things like the Brotherhood of Steel airships and whatnot that are fully functional. We're going to make it a rectangle shape 2D is equal to new rectangle shape 2D shape dot. Like, I mean, from a world building perspective, it's entirely fine to say, you know, most vehicles don't work no more. But I contend if you can, especially once Fallout 4 comes around, if random bandits can operate and maintain suits of powered armor, then random civvies can operate and maintain a combustion engine. All right. All right. Miss Q, this is Godot and C#. Don't like having this. Oh, that's fine. Okay, yeah, there we go. Right, Lunar, right. Effectively, they're like nuclear powered things. But what I'm getting at is there is the presence frequently of all of the machinery associated with internal combustion engines, all of the technology necessary to make and maintain them, and instances of them floating around in the wilderness. And if, random desert cannibal can maintain and run a the microfusion powered armor, then somebody can remake a Model T. Especially given the amount of time that has been indicated. Okay, so we need to have a area 2D. And then it has a shape associated with it, which is going to be a rectangle shape, and that rectangle shape has a size parameter. Okay. Yeah, we'll really need to figure out a way to indicate that particular entities are in a room. And if they are, not to deal with them. But for the time being, we'll just say if an entity exists, it can exist wherever it wants. We'll see. And what is it called? It's... Okay, we need to get something else loaded there so that we can remove that script from the script view. Close. There we go. Okay, good. Stop that. Okay, so if we're looking at an area 2D, we've added its shape as a child, and its shape property is what we want to set it to. Ideally, we could also have a good property here to make it easier to control its positioning, like its anchoring. But I don't think so. size. Times vector 2. We're going to put this one above, so it is... I can't just do a times on that. Oh. Fine. This is all just kind of test code at the moment, so bear with me. Is equal to shape.size. That plus it's half of the x and a negative half of the y. Okay. X one. Okay, so we've got that. We're just gonna do a quick build. Then we're gonna turn on visible collision shapes. So we should have a collision area around here somewhere, but I'm just not seeing it. So we're looking at making it go to the right and up. Oh, well, that's why. Add child area 2D. To run it in Godot for the debugging. Okay, well, that's way too big. It's way too small. Because essentially it's like, it's effectively in the right space, but it is clearly the wrong size. Just getting the run it here, gotta run it here. So in theory, yeah, okay, so if I keep going to the right by about halfway along the texture, it should stop. So I'm running down here a moment because, yep. Okay, so this is positioned at 0, 0. See what the math comes out as here. Okay. The screen size in the game right now is 640 by 360. Like block pixel wise. The actual monitor screen is bigger than that, and the forced resolution of the application when it's running is 1080p, so it's kind of all over the place. Okay, should be half to the right and up half. So it should run right along the top when it's like that, but it don't. App room render. -640, -360. Let's see, this thing's shape is what? I think it's the scaling factor that's getting wonky here. zoom the camera out. Zoom the camera out a lot more. It's not even close. Yeah, I think the scaling factor is playing with it. Oh yeah, definitely that nonsense again. Oh. Yep, okay. Okay, so that's the kind of math we need to use when we are creating them, is we're going to create a barrier around it that is sufficiently large that the player wouldn't be able to avoid it, no matter how fast they're moving. Then we find each of the dead zones and where it is and position them accordingly. So for the super fun added element is, for a texture, the default anchoring is up and left, or is upper left corner. So we'll need to come up with some math for dealing with that, so that we can do things like just center the texture so that we don't have to move the area, and we can avoid the math fiddliness, you know? But we'll still need to deal with scaled values on it. That scale here. Should just be centered. Okay, so now we don't need to assume that it is that we need to offset it just to get it into position. So this should cause them to overlap this way. So the player will appear dead center in it. No? Interesting. Okay. I'm going to be right back. We'll resume after a quick break. And we're back. Okay. Realized one of the things I had been doing wrong here, and that is that it shouldn't be a texture rectangle. I think it's a quad mesh. And we could just use an area 2D. What shapes what things do I have access to here? Instance. I think that's what we want. All right, Drew. Have a good night. Just add a texture, we would add a material. A sprite. So texture rectangles are canvas objects, which behave differently. Like, there's nothing stopping us from doing that. It's just, I want to make sure. I would rather not use a control node, I guess. You could just use a sprite 2D, but that's still... Oh, it's still English there, Drew. Or at least locally. You know, parallel Earth. Yeah, okay, it's a mesh instance 2D. That should work. Instance 2D mesh is equal to new mesh instance 2D mesh dot mesh is equal to quad mesh. Good work. Controlling how players can communicate, or just how communication works in Games Drew, is very powerful. Though, given the prevalence of tools like Discord, the option is it doesn't work in like competitive spaces. It has to be in a spirit of the game space. All right. But we are no longer rendering the texture now. Isn't too surprising. Mesh dot quad mesh. Quad mesh has a size. Okay. Molly is kneading away. Eight. Okay. collaborative movement and interaction like that, Drew, is interesting. I know there was a platformer where each person had kind of their own view of the world and their own way to interact with it. The other person couldn't perceive really at all. Oh, okay, I remember. We'll have to mess with that because yeah, it's inverted. Thanks for swinging by again, Drew. Yeah, that's inverted. Okay, well, we're getting there. We're getting there. Yeah, this creates several new oddities. Is one, entities can only spawn within a certain range of the center of the room. Or at least they cease to be relevant once they are in the room, but try to leave it. We'll see how that plays. But now our quad mesh is upside down. It's like flipped. Oh, that was a thing. There was a thing about that. I know I read something about this. Okay, that's right. All right. So the meshes are rendered as if they are using the 3D coordinate space. But Godot's coordinate space in a 2D world is X is positive to the right and Y is positive down. But when you're dealing with a mesh instance like this, positive Y is up. So it flips it. There we go. So the next thing will end up being calculating where the collision boxes need to go. Where the outside collision boxes will be. it's figuring out the boundaries is going to be the trick. So we need to have the idea that I can't enter this and logic for it. So if the player were to hit this, how do we ensure that they can't go into it? How do we cleanly stop them? We aren't using default Godot like fiction for physics. We're using the physics engine, but not the gravity and friction and all of that. Same way with the edges of the world. We don't want the player to be able to walk through the walls. So we'll start with those collision regions and go from there. I am concerned that there was a empty collision shape there. How did that happen? We'll need to keep an eye on that. We also need to make sure that the map is always on the bottom of rendering. Interesting. Okay. All right. Let's think on this a moment. So we've got our new texture loading in. It's just the bare bones of it. The biggest thing that it's going to add is the ability for us to load in atlases as textures. So we can create wrappers around the actual textures that are the atlas for it. So we can actually have a wrapped texture object, but that's only going to be automatically created for the texture itself, only as needed. So we'll make the wrapped texture and specify it where we want it to be, and we can also create atlas wrapped textures that can emit like multiple of them or similar. But we'll see how that goes. There's some complexity to that we need to look into yet. But we're on our way now. So the next thing is going to be getting the collision in. So we want to make it so that the edges of the room block the player from moving. Not worried about projectiles, not worried about how the enemies move right now. We want to say that the player is blocked from moving along the edges. We can make it so that the enemies are subjected to that as well. Since most of the movement of objects is, again, we're not using the built-in kind of world physics, so it's absolute. We just need to have, like, it can bump into a wall, and we determine what to do there. Yep. Well, we'll see. We'll see. But all right, folks, we're going to wrap up there for the night. I hope you had a good time watching with us. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all of that good stuff. It helps the channel grow and will help you see future streams as you go along. If you'd like to consider financially supporting the channel, you can do so through platform-specific means like subscriptions, bits, memberships, super chats, Patreon, Coffee, and similar things. You can find links to all of my channels and platforms in the link tree, in the video descriptions, and in my Twitch bio. But with all that said, I do hope the rest of your day is good, and I'll see you next time.